Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over a big problem on using conversion factors to solve a oil industry problem. So here we go. It's a long one and it's going to be a long conversion factor type problem. So this is going to be a great problem to get like practice on using various kinds of conversion factors to convert your information to the units that you want. So let's get into this. So in this problem, we have a certain refinery processes 125,000 barrels of crude oil per day. One type of heavy or sour crude oil has 3.5% sulfur by mass and a density of 0.952 grams per liter. The other type of crude oil used has a 1.0% sulfur by mass. This is a quote unquote sweeter or lower sulfur content oil or crude oil, and it has a density of 0.850 grams per milliliter. So the refinery is going to draw out, this particular refinery draws out 60.0% of the sour kind of crude oil and 40.0% of the sweeter kind of crude oil by volume. So the question then becomes, what is the mass of the sulfur that this refinery produces each day in tons? And so we're given a few relationships, a few equalities that we can use as conversion factors. 1 ton, this is an English ton, is equal to exactly 2,000 pounds. 1 barrel is exactly equal to 42 gallons. 1 gallon is 3.7854 liters. 1 kilogram is 2.205 pounds. So this is all going to be very useful in helping us find the number of tons. So what we need to do is we need to break this down into 2 separate conversions, and these are going to be long step conversions, multi-step conversions. So we need to know what the amount of sulfur in tons is produced from the sour oil, which is 60% volume, and the number of tons produced from the sweeter kind of crude oil that has a lower sulfur content, and that's 40% that's brought in by volume. So we got to do those separate conversions and then add them together. So conceptually it's simple, but mathematically it's going to be long. So let's go ahead and do this. So let's go ahead with the more sour. So we know that the volume is 125,000 barrels per day. 60% of that is the sour crude oil. 40% of that is the sweeter crude oil. So let's go ahead and do the sour first. So we're going to start with 125,000 barrels. We're going to put that over 1. And 60% of that is the sour crude oil. So we're going to have to use that as a conversion factor. So remember, 60% means 60 out of 100. Since this is volume and barrels is a volume, we're going to use barrels. So out of 100 barrels of oil that's produced, crude oil, 60% of that crude oil is the sour kind. So we'll put, that's going to be 100. So we're going to have 100. We're going to just put BAR for barrel. For every 100 barrels of total oil, 60 of those barrels is going to be sour, the sour kind. So barrels cancel out. Now we have barrels of sour. And so now we need to convert barrels to something else. Gallons, we know that 1 barrel is equal to 42 gallons. So we can use that to convert to gallons. So since we have barrels on the bottom of sour, we're going to put 1 barrel of sour on the bottom, and we're going to put 42 gallons of sour on the top. So barrels of sour cancel out. Now we have gallons, and so we can now convert gallons to liters using this conversion. So we're going to go ahead and do that. So we got that conversion. Gallons is on top here, so we're going to put gallons on the bottom. So 1 gallon of sour, and we're going to put the 3.7854. So 3.7854 liters, and this is sour, 3.7854. So gallons is going to cancel out. Now we have liters. So we can now convert liters to milliliters, and then we can use the density. So we know that the density is 0.952, so we can convert that to grams, and then from there we can convert grams to tons. But there's going to be multi-steps here. So we got to first convert liters to milliliters. So there, we're going to continue here. So we got liters over there. So 1 liter of the sour on the bottom, and then 1,000 or 10 to the 3 milliliters of sour on top. So that's going to cancel out. So liters on the bottom here will cancel out liters of sour on the top. Now we have milliliters. Now we can use the density as a conversion factor. So let's go ahead and do that. And so we have 1 milliliter is equal to 0.952 grams. So the 1 milliliter of the sour goes on the bottom, and the 0.952 grams of sour goes on top. So milliliters cancels out of the sour. And now we have grams of the sour. We have mass now. So now we got to get the mass to tons. So here we have a pathway. We know that tons is equal to 2,000 pounds. So if we can get this to pounds, then we can convert that. So here we have a relationship of kilograms to pounds. So if we can get grams to kilograms first, and then we can get to pounds. Another way you could do this, if you want to do it a different way, is we know that 1 pound is equal to 53.6 grams. So you could do it that way as well. But here we have kilograms. That would be a 1-step. This would be a 2-step. So we could do it this way. They gave us this, so we'll do it this way. Or you could use the other step. It's up to you. As long as you use the right conversions to get to pounds. Okay, so here we can do 1 kilogram, 2.25 pounds. So we need to get this to kilograms. So 10 to the 3 grams on the bottom is going to be equal to 1 kilogram on top. So the gram, and this is sour again. Sour. So grams on the bottom, kilograms on top. So grams are going to cancel out. 1,000 grams is equal to a kilogram. Now we can use 1 kilogram is equal to 2.205 pounds. So we're going to put our conversion factor. So since we have kilograms on the top, we want kilograms on the bottom. So 1 kilogram is going to go on the bottom. 1 kilogram of sour. And then we have 2.205 pounds of the sour on top. Now we have pounds. We can convert pounds to tons by using 2,000 pounds is equal to 1 ton. And then we're done. So again, forgot to cancel out grams. Grams here, or kilograms, cancels out kilograms. We've got pounds. Now we're going to continue last step. We got pounds on top. We want 2,000 pounds on the bottom. 2,000 pounds of sour. And then we're going to have ton. 1 ton on the top. 1 ton of sour. So pounds of sour cancels out. And now we've got tons. So now what we need to do is multiply and divide. Multiply by everything on the top, divide by everything on the bottom, you get your answer. And when you do that, you get, but wait, there's more. So we almost forgot. Very important information. The 3.5% sulfur. So we got to remember what the question was. So the question was, what is the tons of sulfur? We want to find the sulfur. So what we found out here so far is the ton of the sour crude. So we have one more conversion factor to do. So we need to take this, and now we have another conversion factor, another percentage to use. So since we're told that 3.5% of this crude oil is sulfur, and we want to know how much sulfur is from this crude oil, then we have to use that to convert to the mass of the mass of sulfur from this crude oil. So again, as 3.5%, that means that out of 100 units of your crude oil, 3.5 of those units is going to be sulfur. So in this case, since we have tons, that means out of 100 tons of crude oil, the sour kind, 3.5 tons is going to be your sulfur. So we need to do one more conversion that we almost forgot. That's very crucial. So we're going to put, since we have tons of sour crude oil on the top, we're going to put 100 tons of sour on the bottom. And so on top, we're going to have 3.5 tons of sulfur. So sour cancels out. Now we have sulfur. Now we can go ahead and multiply and divide and find our answer. And when we do that, we get 43.80. So we get 43.80 tons of sulfur from this here, from the barrels of sour crude. That's 60%. Okay, so next, I need to change this. This is, I put the decimal point in the wrong area, so it should be 438.0 tons. So that's the correct answer. Now, this is only for the sour. Now we have to do the exact same calculation. So the exact same calculations for the sweeter or low sulfur content crude oil. The only difference between the series of calculations that we're going to do now for the sweet that we did for the sour is that the percentages are different. So instead of using 60 out of 100 because of the 60%, here, where's the 60%? Oh, here. So we're told that the refinery is drawing 60% of the crude oil that it draws is sour, and 40% of the crude oil it's drawing is the sweeter, low sulfur content oil. So that's going to change. So instead of 60 over 100, we'll have 40 over 100. So we'll change that now to 40, right? So there's 40. And the other difference is going to be the density that we're going to be using for that as well. So we use the density 0.952 grams per milliliter for the sour. We're going to have to use the 0.850 density for the sweet. So we're going to have to change that. So let's go ahead and change that. 850, so 850. And then finally, the percent sulfur in the sweet crude oil. We're told that that is 1.0% sulfur by mass, whereas the crude was 3.5. So here we have 3.5 out of 100. So we're going to have to change that to 1.0. So 1.0. And so now we have everything set up for the calculation for the sweet oil to calculate the total amount of sulfur from the sweet crude oil. So again, everything is the same. We're converting barrels of the total oil to barrels of the sweet. So this should be sweet now instead of sour. So this is sweet. I'll just put SWT for sweet. So all of this is now sweet. So we're dealing with sweet here. Sweet, 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 and so on. So again, so this is going to be sweet, SWT. That's bars. This is SWT, SWT for sweet, SWT, 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 SWT. Okay, so now that it's all set up for sweet, we can now calculate the amount of sulfur from the sweet. Now we're going to have to put this to the side because we're going to have to add these together. So 438.0 tons of sulfur from the sour. Now we'll calculate how many tons of sulfur from the sweet. So when we calculate this out, we get 74.49. So here we get 74.49 tons of sulfur. Okay, so what's the total amount of sulfur? We just add these together. So it's going to be 438.0 tons plus the 74.49 tons of sulfur. And when we add that together, we get 512.5 tons of sulfur. Now we have to figure out what our sig figs are. So when you're multiplying and dividing, your sig figs are going to be related to the least number of sig figs. So remember, when you're multiplying and dividing, your answer should have the same number of sig figs as the least number of sig figs of your measurements. So here we have 3 sig figs. Here we've got, this is going to be, I didn't write the 0 down, but this is going to be, where's the percentage? Here, 3 sig figs here. So that's actually 3 sig figs. This is 2 sig figs. Here we have 4, or actually 5. Here this is exact, so we can ignore that. This is going to be 3, or no, that's 5. Oh no, sorry, 3. This is 3 sig figs. Exact. This is 4. This is exact, and this is 2. So the least number is 2 sig figs. So we have to limit our answer to 2 sig figs. So this was supposed to be 2 sig figs. So we have 1, 2. So we should limit it at the 3. And so I'm going to underline the 3 there. And then the same thing for this one. This should be limited to 2 sig figs as well. So it'd be this one and this one. So now here we're adding. So remember, the rule is different. When you add or subtract, your answer should have the same number of decimal places as the least number of decimal places. Now, when you say decimal places, it doesn't really give justice to what you're supposed to be doing. It's better to think about the least precise placement of your significance or your measurement. So what do I mean by that? The least precise. So here you'll notice that the significance, the last digit of significance, is in the tens place. Here, the last digit of significance is in the ones place. So even though technically, according to the rule, that the way it's sometimes said is it has, as far as decimal places go, these both have 0 decimal places. But what you should be actually looking at is not decimal places, but the least precise placement, right? What place has the least precision? So here we have tens place. So your measurement here ends at the tens place. This one ends at the ones place. This is more precise. This is less precise. Your answer cannot be more precise than the least precise measurement here. So since your last digit ends here at the tens place, your answer here should not be any more precise than the tens place. So here, we got to stop at the tens place. So we got our last digit of significance here. So then we're going to drop it off there. And so our final answer would be 510 tons of sulfur. And so that is the answer. Don't put a decimal point here. If you put a decimal point there, then you got 3 sig figs. We don't want 3 sig figs. So that is 2 sig figs. So 510 tons of sulfur is the total amount of sulfur gotten from this refinery. That's it for this video. I hope you enjoyed the video. If this was helpful, if you learned anything from this video, please like the video, share the video, hit that like button. Also, subscribe to my channel. Make sure you, when you do, click that notification bell. When you do that, click all so you can be notified by all the videos I put out. Put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to go over, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me. Have a great day.